Today we are going to discuss the three equations of motion. We'll derive all these three equations. What are that? First equation is Vf is equal to Vi plus At. Second equation is S is equal to Vit plus 1 upon 2 At square. Third equation is 2As is equal to Vf square minus Vi square. These are the three equations that we are going to derive. First equation of motion. For example, there is a person that starts from here, that is its initial velocity, and he or she covers a displacement consuming a time as well, and then he finally reached to its destination place, that is its final velocity. So we know that the rate of change of a displacement is known as velocity. So change in velocity into time and consuming a time, that is the formula of acceleration. So we are going to derive through acceleration. Acceleration is equal to change in velocity upon time. Change in velocity is basically Vf minus Vi, because it has covered the displacement, and change in velocity is basically Vf minus Vi. So we can put the value instead of change in velocity. So acceleration is equal to Vf minus Vi upon t. Here t is dividing, here it will move and multiply, so it will be At is equal to Vf minus Vi. We have to make this first equation Vf is equal to Vi plus At. So Vf will remain here, minus Vi will move there and become plus Vi. So it will be Vi plus At. That is proof that it is a first equation. Now we'll be moving through a second equation, that is S is equal to Vit plus 1 upon 2 At square. Okay, in second equation, a person started from initial velocity and covered the distance as well as covered consumed time and reached to final velocity. So now distance means it has a velocity as well as time. So we'll be using this formula that distance is equal to velocity into time, that it consumes a time and having an initial to the final velocity as well. But here the velocity will be taking the average velocity to prove this equation. And how to take an average? That will be adding both values, that will be initial velocity into the final velocity, and will be dividing it by the total value, that is 2. So S is equal to V into T. We will be putting the value of V, that is Vi plus Vf upon 2 into 2. Now S is equal to Vi plus, can we put the value of Vf, that is Vi plus At. So we are putting the value Vi plus At, dividing it by 2 into T. Now it will be 2Vi plus At upon T into T. 2 into T. Here dividing by 2 means it is dividing by 2Vi as well as 2At as well. So we'll be separating it to make the equation. 2Vi multiplied by T will be 2Vit and divided by 2. Then plus At into T will be At square upon 2. 2 to 2 cancel. It will be Vit plus, here dividing by 2 means 1 upon 2. 1 upon 2 we can write here 1 upon 2 At square. 180 square or 80 square, both are same, so we'll be writing 180 square upon 2. So that is the second equation. S is equal to Vit plus 1 upon 2 At square. Now the third equation, that is 2As into vf square minus vi square. So we're proving that. Now it basically, this third equation is obtained with the help of first and second. Okay, so here there are some steps to derive this third equation. First of all, we'll be taking the first equation, that is vf is equals to vi plus at. We'll be squaring it, that is the condition like to prove the third equation, that we have to take first equation and squaring on both sides. When we square on both sides, vf square is equal to vi plus at square. It will be vf square. Now that is basically a formula. Vi means a, at means b. We know a plus b whole square is a formula, that is a square plus 2ab plus b square. So that is a formula. So we'll be opening it like vi square plus 2viat plus a square t square. That is, we have opened that equation. So now vf square is equal to vi square plus 2viat plus. Now here if I write 2 upon 2 a square t square, does it matter? Or I can simply write a square t square. Both are same because 2 to 2 is equal to 1. So every value that multiply with 1 is the same, answer will be same. So there will be no change in the answer. So I can also write here 2 upon 2 a square t square. Now vf square is equal to vi square. Now here in both these we'll be taking a common, that is 2 and a. Basically for proving the equation, that is 2a s is equal to vf square minus vi square, we have to prove that we'll be taking 2 and a as a common. T is also common but we will not take, but because we have to prove this equation. Now but first of all the equation will prove, that is second equation, then through the second equation we'll be proving third equation. Now we have taken common. Now it will be vit plus 2 is common, 1 upon 2 a, 1a is common, a is left, t square. vit plus 1 upon 2 at square is the second equation. It is proved. So now vf square is equal to vi square plus here 2a. Instead of this all I can write it is equal to s. So it will be simply equal to s. Now for making this equation, vi is plus adding here, now there it will be subtracting. It will be 2as is equal to vf square minus vi square. So we have proved this equation as well. So there were basically three equations. vf is equal to vi plus at, s is equal to vit plus 1 upon 2 at square, 2as is equal to vf square minus vi2. All are proved.